Welcome everyone to this session. My name is Sheng. I'm from Rancher Labs. Today, my session's topic is Introduction to Longhorn, open source cloud-native storage for Kubernetes. I'm also the maintainer of Longhorn, and I've been spent last couple years, in fact, last few years, working on Longhorn. So let's get started. So as you might already know, that Longhorn is a CNCF project. And the Rancher Labs has developed the project and then contributed to the CNCF. And the Longhorn is a 100% open source distributed persistent storage for Kubernetes. You can find more information at longhorn.io. Our target for Longhorn is getting persistent storage everywhere. As you might know, that Kubernetes is already pretty good at handling the stateless workload. But coming to the stateful workload like database and others, there always be some concerns. So Longhorn's exist is trying to also address that. We're not owning a storage solution, and we are a storage solution built just for Kubernetes. And of course, we're building on top of Kubernetes to be cloud native as well. There are a few design principles for Longhorn. The first thing is we want Longhorn to be reliable. So we choose to do Longhorn in a crash consistent way. As you might see later, every data you write into the device provided by Longhorn, we are going to be write into multiple replicas synchronously. So once, if you have the scenario that note down, and as long as you have one replica, you can recover all your data. And also, we have built in multiple layers of protection against the data loss, including Longhorn building snapshot mechanism and the backup mechanism. So the snapshot mechanism is going to provide you to revert back to previous snapshot inside the cluster. And our backup mechanism is in fact backing up the snapshot to the outside of cluster, for example, AWS 3. And then you are going to have the backup safely stored outside the cluster. So even in the worst case scenario, you have your whole cluster went down, you can still recover your data easily. And the second thing is we are really focusing on the usability. In fact, it's similar to all the products and the projects created by the Rancher Labs. We really value users' experience and make sure to provide the best user experience for to the customers. And for Longhorn side, we include one-click installation, and you don't need to any configuration for installing Longhorn the first time. And of course, they are going to be, after you try it out, you can customize it. And also, we have taken a lot of users' feedback to polish our user experience, especially on the UI and how we can support Kubernetes better. Because there's some concept like PVPVC and storage class, those are not really that straightforward to the newcomers of the Kubernetes. We choose to integrate part of the features and also expand the Longhorn's scope a little bit to try to help users to get the best experience of using Longhorn on top of Kubernetes. The third thing is the maintainability. So we want Longhorn to be easy to understand, that in contrast of, for example, Ceph, which is, of course, very famous and has been mature for years. But the problem we had with the Ceph before at cloud.com, which is my previous company, is that we have very many customers think Ceph is really too complicated to maintain. And for the crash map mechanism, you need to really understand what it's doing to avoid that putting two blocks or two replicas of the same volume into the one disk. So that part is something we want to avoid. We want to address that problem through the easy to use Longhorn, easy to understand Longhorn design, and also provide multiple tools for user to easily recover even in the worst case scenario. So as you can see later, Longhorn doesn't have a stripping. And in the worst case scenario, even you have a whole system went down, and as long as you only have one hard drive, you can completely recover your data from that one hard drive. And the Longhorn also support upgrade without interrupting the workload. We are still working on the supporting 100% of the case Currently, the onion bug fixes, upgrade framework bug fixes, we're going to break the compatibility, then we'll require some offline upgrade. Otherwise, by default, we support upgrade without the interrupting workload, so you can read write data as you upgrade the Longhorn engine to the latest version. So the latest Longhorn release is released at late July. It's 1.0.1. So in fact, Longhorn has been here for a really long time. And many people asking, is Longhorn ready for production? And the answer now is definitely yes. We'll spend a lot of time to test and also get a lot of user feedback. And the very first GA release, 1.0, in fact, is very successful. And we can see that now with 1.1 and upcoming 1.1.0 release, the Longhorn will be getting better and better, and also, of course, going to meet your production requirements. So the Longhorn itself is enterprise-grade distributed block storage software for Kubernetes, and we support sync provisioning, and we, of course, as I mentioned before, support volume snapshot and backup restore. And we also support volume expansion, currently, unfortunately, offline only. And we also support cross AZ replica scheduling, which is basically mostly targeting for the cross AZ Kubernetes deployment, like in some cloud providers, for example, K8s. So we support storage type for node and disk selection, and we support cross cluster DR volume with defined RTO and RPO. The RTO is recover time object, and RPO is recovering point object. So in using this feature, we essentially able to replicating the volume from the main cluster to your backup of cluster. So in the event that the main cluster went down, you can easily spin up the backup cluster in no time. As I mentioned before, we support live upgrade of Longhorn software. And also we have building a very intuitive UI, and of course, one-click installation and so on. So I will demonstrate some of this feature later. So let's talk about how Longhorn architecture looks like. So here we have 3 nodes, and you can see, and those 3 nodes, they have hard drive and RAM and CPU. Some of the hard drive SSD are marked as gray, means that they are not usable by Longhorn. And the Longhorn, once Longhorn is stored, we are going to deploy engine instance manager and the replica instance manager on every node, except for the node that doesn't have storage provided to Longhorn. We are not going to deploy replica instance manager here. So in this, and now Kubernetes is asking for a pod, and the pod needed to have a volume. So Kubernetes is going to transfer this request to create a volume to the Longhorn storage class and Longhorn provisioner. And the Longhorn, we are going to create 2 replicas. So we are based on how big the volume is and what's the scheduling policy. We are choosing to place 2 replicas on the node 1 and node 2. And then we are going to start engine process in the engine instance manager to connect it to those 2 replicas. And the engine process then are able to expose a block device on the local node and connect that to the volume inside the pod. So when you have multiple pod and asking for multiple volumes, the same thing happened. We create a replica first, and then we create engine, and then we provide the volume to provide the data to provide the block device to the volume, and the third one. So the whole process of creating replica and engines only take a couple of seconds. So that is how fast the speed of attaching and detaching volume is supposed to be in the Longhorn. So as you can see here, we are not, the engines and the replicas, in fact, one group of them contains everything in the data path. They're not really in interaction with each other. So that is the first advantage of Longhorn design. So the data path of the Longhorn doesn't interfere with any other volume. So even one volume went down, there's no way in theory to affect any other volumes or any other engines or replicas. So by doing this, we're avoiding to have a highly available engine to create for whole clusters, because it's a pretty hard thing to do. So instead, we have a small engines and replicas that dedicate to each volume. You might ask a question, why engine and replicas are running inside those instance managers rather than just starting as a separate pod? In fact, for the first few versions of Longhorn, we started the engine and the replica just like the separate independent pod. But later we found out because the engine of the replica take a pod count, and the Kubernetes have a pod count of 110 maximum limit for each node. So in fact, it's very easy to hit that count when you have a very big node with a lot of volume. So since the 1.6 release, we have introduced the engine instance manager and replica instance manager, who are essentially pods. And the engine and the replica, in turn, we are going to be started as a process instead of pod. So in this way, we are able to first attach and detach much faster, and also we are not going to have we are not going to take much resources from the main Kubernetes cluster. Since every pod, on every node, they're only going to be like instance manager and 2 instance managers and like probably 1 Longhorn managers and some other. So it's not going to take like, I think 4 or 5 pod per node. All right. So so what if the node 1 went down? So as you can see that if the node 1 went down, of course, we're going to lose the pod A on node 1 and the engine and the replica along with it. But we still have a replica on node B, right? The node 2. So the Kubernetes, we are going to start the pod A in the other node, which in this case, node 3. And the node pod A, we're going to ask for the same volume, which is blue. And we're going to create an engine for this volume and connecting to the existing replica, because we know that on node 2, there's a still replica available to us. So in this way, we are making the highly available volumes without really have a complicated logic to handling highly available engines. So that is the one part of the design, like make those things easy, make the high HA volume easy in the Longhorn. But in fact, this Longhorn can exist and can use this microservice pattern is because of Kubernetes. It's because of Kubernetes give us the ability to easily start in pod and scheduling them around the cluster and make sure that they can easily be monitored and handled. So we don't need to invest a lot of efforts to manage those microservices, but to rely on the Kubernetes on that. That's also why Longhorn is built on top of Kubernetes. So here, I want to share a quick demo of Longhorn. So first, you can, as you can see, right, this is the typical Rancher installation with 3 clusters. We are going to do the demo using demo and the demo 2 environment cluster. So the first, of course, we have no Longhorn installed. So let's do the one-click installation first. So I go to the apps and click launch, which is essentially launch. What's wrong here? Okay, essentially a launch application using Helm chart. So we don't need to configure anything, and by default we are using the root disk for the storage, provides the storage, and we can click launch. So here, as we can see from the workload, now there are multiple components are starting. The first one, the Longhorn UI already started, and the Longhorn manager and the driver deployer are going to start. So the driver deployer, in fact, is the way for Longhorn to detect the user's environment and deploy the appropriate driver. Currently, it's most likely CSI. And previously, we do support flex volume in some early versions of Longhorn. So you can also see that we have the image, engine image distributed and to the every node. And the instance manager, as I mentioned before, are also here. All right, so I think it's still deploying. Let's take a look at the UI. I think it should be done very soon. All right, so in fact, UI is ready. This is the dashboard of Longhorn. From here, you can see the overview of your whole cluster. On the left side, you can see we currently have no volume. And in the middle, we have some the summarization of what's the current stage of Longhorn and how many space Longhorn can use. And the right side, you can see the node status. And going down here, you can see that we can have the event log, and this is also, we are using the Kubernetes event log mechanism to provide this part. So for the next page, we're looking at the node page. And node page, in fact, it contains both node information and also the disk on the node. So you can see that though the first, let me collapse this more. And the first, you can see that there are 2-3 nodes, and no replica has been made. And also the allocation means that this is the total size of the volumes, nominal size I can allocate to this node. And also on the right side is what's the real time disk usage and the size of what can be used by Longhorn. So for each node, in fact, we can click the edit here and see the more details, like where the node disk is. And as you can see right now, by default, we are using var_lib Longhorn to provide storage. So for the volume page, there's nothing right now. And for the backup page, as you can see that because the backup target is not set, we're not looking, we cannot see any backup here. So my next thing, we're going to be set the backup target, which I'm going to point into S3. And then let's go back to the backup page. So now we can see the backup page has been refreshed, and we have seen that there are few objects in our backups. So we are going to look deeper into this later. So now let me try to deploy Longhorn. Deploying an application using Longhorn. So normally what I'm going to use is the WordPress. Let me set up WordPress password and make sure that you have enabled persistent volume for Longhorn. And also MariaDB password. And click launch. All right, so as now the WordPress is deploying, as you can see in the Longhorn volumes, in fact, 2 volumes has been created automatically because of Kubernetes talking to Longhorn using the CSI interface. And they are attached and they are now healthy. And that's to look into the details. Oh, in fact, before that, we can see that from this overview page, we can see this is the PVC-5FCE something, and this is the PVC name, also the PV name. But you can see more information regarding it, like say what is the PVC name with this PV, and also where the namespace is, which namespace is used by this PVC PV, and which workload. In fact, this is the one of the user feedback we have taken and really works well. So this is the workload is attached to the MariaDB, and you can see this workload is attached to, in fact, to the WordPress itself. If you click here, you can see that, oh, this volume is attached to the WordPress deployment. In fact, it's replica set, and the pod state is running. So now you can see the more information here. Let's take a look at the volume itself. So here, you can see the UI of the volume detail page. And left side, you can see all the details of volume, and including what's the status and what's the condition and where the volume was attached to. And for in this case, it's attached to demo 3 with this block device. And what's the nominal size and what's the actual size, which is the size that taken on the disk. On the right side, you can see there's 3 replicas, which is the default in Longhorn. And also, you can see that there's 3 replicas, in fact, on the 2-3 different nodes. And you can also move your mouse in the var_lib Longhorn with this data directory here, and you can see that this is it's basically the data. In fact, it's stored in the var_lib Longhorn replicas. And that's what I mentioned. Only if you have 1 disk available, in the most worst case scenario, then you can recover full data because every data of this volume is going to be written here. Down here, we have snapshots, and you can easily take a snapshot, and which is, of course, going to make inside cluster, and then you can create a backup. And the backup is being created, and in fact, we are going to create snapshot first, and then ship this snapshot to the backup store. And this is the progress we'll see, and you can see that the backup we are going to contain the full data. Even you can see that the snapshot is like 0 size because we are seeing provisioned, but this is the real size of this volume. And here you can see you can set the recurring snapshot and backup. Let's try to set a backup like every minute for the demo purpose, and return last 5. And down here, there are more event logs, which is going to show you what's the latest status of this volume if you are looking for some logs and stuff. All right. So in fact, that's set up for the recurring backup for another volume as well. And let's do still backup every minute. And save. All right. So in a moment, we should be able to see that the backup was updated since both backup scheduling should be running. Okay, let's go back to the WordPress. Let's make sure that WordPress, in fact, is working. And as you can see right now, this is on the demo and apps and the WordPress. All right, so let's log in. Make sure that we have right password. All right. Let's go to our post. So here, let's add a post called Longhorn Demo. Okay, let's take a look. Yeah, so this post was added. So what if I want to have what if I want to set up a DR volume for this cluster? So then I will want to have those backups like this volumes used by this WordPress application to be replicated remotely to another cluster, right? So that's what cluster demo 2 for. So in demo 2, in fact, we already have the Longhorn system installed, and it's also at the latest 1.1 release. All right, so let's take a look at backup. We should see some backups from the first Longhorn installation. You can see those 2 are, and in fact, for the first Longhorn installation, we can see things here as well. You can see the last backup was created like 1 minute ago and stuff. All right, so now for this 2, I'm going to create a DR volume for those. So the DR volume is basically replicating the data from the backup store and make sure that when you activate it, it's keep it sync with the upstream backup store. So as you can see here, there's a red exclamation mark here saying not ready for workload, of course, because this volume is still watching the backup store and the replicate data. So let's modify something at the Longhorn's blog. New post. Okay, so let's take a look. So this DR demo has been, this post has been added, and now let's wait for a while for this DR volume to be shipped to the backup store and then incrementally restored from in the DR volume side in the backup cluster. All right, so now we see the last backup was checked out and a few seconds ago. That means it's definitely going to include in backup that have our new post. So that's going to activate the DR volume. All right. In fact, another thing you can notice that for those 2 volumes already pretended to have the information from the previous workload. And now I can just create PVPC out of it. And we're going to use the previous PV and PVC. Yeah. So now the PV and PVC has been created, and you can see that this is using the previous PVC name, which is in fact very important for the stateful set. Okay, let's go back to the demo 2, which doesn't have the WordPress application running. And that's going to launch the WordPress applications. Make sure we have the same password. And make sure we are selecting the right PVC for this application. You notice that in fact for the MariaDB, there's no place for you to input the PVC name because MariaDB is running as a stateful set, which the PVC name is in fact predefined. That shows how important it is for the storage system to remember what's the PV and PVC name from the original setup. Let's click Launch. And now you can see from this UI that the new volumes are being attached, and they're now attached. So that means that Kubernetes has successfully recognized them and associated them with the data of the WordPress. And now here, the WordPress is still deploying. Let's wait a while. Okay. I think WordPress just become running, and let's take a look if that's true. All right, yes. So now you can see that the Longhorn DR volume demo is in fact the post we created after we created DR volume in the new cluster. And this means that our recovery from the main cluster is done. So that concludes my demo. So here's some latest update on Longhorn. Our latest release, which is released in middle July, is 1.0.1 and is GA quality and ready for production. So I currently have 1.7 thousand GitHub stars, which is due by the day that we do this recording, and it has been doubled since we joined the CNCF. And also, our worldwide node count have exceeded the 10,000, and that has been more than quadrupled compared to the 1 year ago. And you can check metrics.longhorn.io for more details. We currently have more than 700 users in our 2 Slack channels. The number has been doubled since we joined the CNCF. So Longhorn has an official channel in the CNCF called Longhorn, of course. And also, we have another Longhorn Dash Storage channel is available to the user in the Rancher user Slack channel. Because this was the old Longhorn channel, and we haven't had the old user migrate to the new channel yet. So, of course, as a CNCF open source project, contributions are always welcome. We really appreciate the support our community member give us during the development of Longhorn for the past few years. So you can easily file a bug report enhancement suggestion at the GitHub/Longhorn and Longhorn. We really love to hear your feedbacks. So thank you, everyone. Enjoy Longhorn.